right, so let's go ahead and get started. We talked about We talked about power yesterday, and today we're actually going to do the calculations and the math for it. Don't forget, tomorrow is a half day. I think I only get you for 20 minutes, so you can still come to Zoom. And we're just doing more math tomorrow, so won't be too hard. Well, it might be long, but it won't be too hard. So I did give you the problems I'm going to be working on today. So if you just want to look at it, save a copy, write it on your own piece of paper and number it, or you can print it if you want to. However you want to do it, it's up to you. But those are the problems I'm going to be working on. So the formula for power is work divided by time. So the P is going to stand for power. And like I said, it's really confusing because power is going to be measured in watts. So just really be careful on those W's. Don't get work and watts confused.
Oh, never mind. I just checked my Gmail again. Turns out I successfully switched accounts.
Okay, great.
So I'm good. I'm pretty sure my brother knows about this too.
Sorry?
I'm pretty sure my brother knows about this too.
Probably. If he read his email. Some people don't read their emails.
Mine was my algebra teacher sent it on geometry. I mean, in school.
Oh, so it's not a school thing then. It's just your teacher?
No, it's a school thing for everyone.
Oh.
For every student. She just sent me the instructions of how to do it. All of us the instructions.
All right, so back to the formula. P stands for power, and that's measured in watts. W stands for work, and that's measured in joules, which we already know about. And T is going to stand for time, and that's measured in seconds. And then, of course, there is a triangle if you like to use the triangle. It's power. Oh, no, it's not power. Sorry, power does not go on top. Sorry, that's just a habit.
It's work, and on the sides, it's power and time.
Yes, thank you. Work goes on top, power and time go at the bottom. That's the right formula. That's the right triangle. Okay, so first problem. A small motor does 4,000 joules of work. So 4,000 joules, that's our work. In 20 seconds, that's our time. What is the power of the motor in watts? So we want power. We're looking for P. So easy peasy. Power is work over time. Work is 4,000. Time is 20. So you're just doing 4,000 divided by 20. And that's 200. And then the units for power are going to be watts. So it's 200 W. So like I said, it's not too hard. It's kind of like our work formula. Our work formula was pretty easy. It is going to get hard, however, when we start converting formulas, adding them together, combining them. That's what's going to make it a little bit more difficult. So number two. How much power is produced in 18 seconds? I can't read today. I'm so sorry. If 68 watts of power, so that's my power, is produced in 18 seconds, that's my time, how much work is done? So we're looking for our work. If you're using your triangle to find work, it's just power multiplied by time. But I'm going to use my formula and I'm going to rearrange it. So power equals work over time. Plugging in my numbers. Power was 68 watts. I'm looking for my work. And my time was 18 seconds. So to solve this problem using algebra, you need to get rid of this 18, and you're going to do that by multiplying both sides by 18. Since it's divided, you multiply, you do the opposite. That cancels out 18 on your right, so now you have 18 times 68. That's 1,224. So your work equals 1,224. And then your units for work, since that's in energy, it's joules. Again, pretty simple.
Could you do that the same way if you had work and you didn't have time?
That's actually the next problem.
Oh, okay.
Ready? Okay. Look at you jumping ahead. Okay, so now, like Cameron asked, we're looking for time. How much time is needed to produce 720 joules? So that's my work with 90 watts of power. So that's my P. I'm looking for time. So no, in this case, you wouldn't multiply. If you're looking for time, it's just work over power. So work divided by power. So you can just solve it like that. But I'm going to solve it using the formula. Again, power is work over time. I know my power was 90 watts. My work is 720 joules. And I'm looking for my time. So here's where algebra gets a little bit tricky, because what we're looking for is a denominator, and we don't want it as a denominator. So we need to do two things. First, we're going to multiply both sides by t. So that crosses out t over here. So we're left with t times 90 equals 720. And then all you need to do next is just divide both sides by 90. So it's 720 divided by 90, which is our work divided by our power. So 720, divide that by 90, that's going to be 8. So our time is 8 seconds. That one was a little bit more complicated if you choose to use the algebra way. So I do suggest you using the triangle to find time. It makes it a whole lot easier. All right, number 4. If a power lifter raises a 1,000 Newton weight, so remember Newtons measures force, a distance of 2 meters, so meters measures distance, in 0.5 seconds. That's my time. What is this power output? So we're looking for power again. And power is work divided by time. So again, what is a problem we have here? What are we missing?
Our work.
We're missing work. So we already know the formula for work. We've done this already. This is what we learned last week. Work is force times distance. So W stands for work, which is measured in joules. F stands for force, not for, which is measured in newtons. And then we have the D, which stands for distance, and that's measured in meters. So in order to find work, we need force and distance, which we have. So this is a two-step problem. The first thing we need to do is we need to solve for work. Our force is 1,000. Our distance is 2 meters. So 1,000 times 2, work is 2,000 joules. Now that's not our answer. That's just what we needed to do first. Now we can do our second step, which is to find power, which is what we needed to do. That's work divided by time. We just solved for work. We know that's 2,000. Divide that by our time of 0.5 seconds. That's going to be 4,000. Yes. So power is 4,000, and our units for power are watts. So that was a two-step problem. Again, you already know the formula for work. It's just force times distance. We spent a whole week on that. Hopefully you feel comfortable to convert it to work first and then convert to power. Now I'm going to throw a three-step problem at you. Are you ready? It's easy, I promise. It's just time consuming. All right, Tara, who has a mass of 62 kilograms, so that's our mass, gets on an elevator. The other elevator lifts Tara 6 meters. That's our distance, in 10 seconds. 10 seconds is our time. How much power was used? So we're looking for power. All right, we're looking for power, and the formula for power is work divided by time. But we don't have work either. So the formula for work is force times distance. But we don't have force. We don't have anything that's measured in newtons. We have something that's measured in kilograms. But remember, if you have a mass and it's going up or down, we know the acceleration acting on it, right? It's always going to be the same number. What number is that going to be?
9.8.
9.8, gravity. So remember, force is also equal to weight. They're the same thing. And the formula for weight is mass times gravity. M stands for mass, which is kilograms. And G stands for gravity, which is 9.8 meters per second squared. So this is what I'm talking about when I said it's a two-step problem. Very first thing we're going to have to do is find force, which is weight. So that's our mass times our gravity. Mass was 62 kilograms, and we always know gravity, that's 9.8. So 62 times 9.8, our force is 613.8 newtons. That's just our first step. We're not even done yet. Now we can solve for work. So our second step, work equals force times distance. We just calculated our force. That was 613.8. Our distance is 6 meters. So 613.8 times 6. Work is 3,682.8 joules. But again, we're not done because we need power. So our last and final step, power is work divided by time. We just calculated our work. That's 3,682.8. Divide that by our time, which was just 10 seconds. That is 368.28 watts. Got a little power hungry on our assignment today. So I made a lot of questions like this. There's probably like 4. Sorry. But it's easy, right? We can do it. We're good. I'm here if you need help. Don't worry. All right, you ready to try one on your own? All right, do number 6 on your own and send me the answer in the chat room. You could send it on private or you can send it to the class.
You said for which number?
Number 6.
Okay.
I already got someone who sent the answer. Let me check it because I don't really remember. All right, yes, all 4 of y'all are correct. Good job. For those of you that haven't done it yet, there we go. All right, so go ahead and do number 7 on your own. All right, I already got a couple people answering. Good job, good job. Yes, it is 60 joules. So in order to find work, you're doing power multiplied by time. So you just have to multiply those 2. That's probably the easiest way to do the formula. You don't have to divide like when you're solving for power. All right, let's do number 8. Number 8. Oh my goodness, why am I typing the wrong thing? 15 times 20. All right, got a couple of people answering that. Good job. It is 10 watts. Good job for using your new units. It is 10 watts. That one was a 2-step problem. You did have to find work first. Remember, work is force times distance. And then with work, you can find your power. All right, let's go ahead and do number 9 now. Number 9. Y'all are fast. I barely underlined all my stuff.
It's the greatest invention. It's called a calculator.
Yeah, but I gotta show my work, you know? You're not showing your work? I guess you don't have to. I mean,
I don't have to, but I can if I want to.
okay.
Look, if it doesn't tell me to show my work, I ain't gonna show my work. Unless the only time I do it is when it tells me, or if I get lost in something, then I have to retrace my steps.
Well, I don't think on today's assignment you have to show your work, so you're good. So I will tell you this is a 3-step problem. Hi, Jacob.
I did it in 3 seconds.
Nice. I'm still doing it. I'm not done yet. Uh-oh, I did not get that answer. Did anybody else get a different answer?
I got 1.125.
Let me see. Maybe I did something wrong. Because you got 1.1?
1.125.
Did you use 9.8?
Yes.
That's what I used.
So that gives you 8.82. Okay, I got what Jonathan got. Anybody else get that one? And then I multiplied 8.82 by my distance, which was 5,
Supposed to use 9.8.
for gravity. Because you have mass right there, kilograms. You need to change the kilograms to newtons. So I got 44.1. And then power is work divided by time. So I divide 44.1 by 4 seconds. And it's 11.025. All right,
Oh
Gabe, what
yeah, I just
did
did
you
it
do?
again. I might have put something in wrong.
All right, I'm going to wait for a couple more people to type in what they got because I don't want to move on until we get number 9 down.
I gotta remember not to rush through things.
Yes, that's why I show my work. Okay, I got 2 more people that got it. Great. So this has to be the way we do it then. All right. And lastly, number 10. Go ahead and do number 10 for me. That was fast. Okay, I'm not even done, so. Oh, that was supposed to be a time one. Whoops. All right, yes, good job. 1,176 joules. Great job. Okay, so on today's assignment, it's not multiple choice, it's fill in the blank. But for the problems where it's 3 steps, I have you filling in 3 blanks. So that way you can see where you went wrong. Either you missed the very first one or you missed the very last one. Maybe you missed the middle one. So that's why I have those 3 blanks. So that way we could follow your steps to how you get there. Don't round, don't put any decimal, oh no, put decimals, yes, put decimals. Don't put any commas, no commas. I think there's only one problem where I want you to round after the decimal, but other than that, all the numbers are what you get in your calculator. So I'm gonna stay on Zoom the whole time. If you wanna work on your calculations while you stay on, that's fine with me. But right now, if you don't understand what we just did as a class, let me know right now so that way we can go through it more slowly. I know I kind of rushed through the back page. If you need any help, stay on. If you think you got it, you can go.